Një, dy, një, dy, një, dy, tre, test, test, një, dy, tre, prova. Një, dy, tre, prova, test.
good with time? Shall we start? Okay. So, all right, everyone. We are starting day 2 on LAS in the second track. We already had the first on the track 1, but this is the first talk of this track. And today I'm going to be presenting about my new kind of pet project about boxes. And yeah, I hope I don't get ahead of myself. I have this tendency of just saying everything before the slides come up. So boxes, for those who are not familiar, is the virtual machine management application that we have in GNOME. It has been designed with this idea that you don't need to know about virtualization, about operating system things. You should just give a couple clicks and get yourself a virtual machine. But at the same time, after you create your virtual machine, you should be able to go there and do your advanced stuff with it. So I've been really trying to have like this design language where like creating a machine, it's really, really simple, and configuring it is actually where we expose a lot of internal technical terminology for those who actually want to. So the pet project itself is 3 main topics that I wanted to address, which is moving from GTK 3 to GTK 4, moving from SPICE to libmks, and moving from having like a default packaging first app to a Flatpak first app. So boxes had a lot of like historical runtime checks and things because of a consequence of the Linux fragmentation problem, the fact that not all distributions can guarantee you the same platform, the same environment. So I felt that it kind of hold us back for some time, and that's one of the main motivators. But yeah, so this is basically a summary of what I'm going to be talking today. I want to really show how we got to where we are, what is the state of the stack, and how things fit in together. The main modernization needs that I have observed, like I think things that should be prioritized. My sustainability concerns, which is basically the how or the why actually I'm doing this, because at some point the bus factor got to 1, and then I got assigned to other work, and then suddenly the bus factor is actually not 1. So how I want to revert that, I really love doing boxes, I really love doing app development, and I find a lot of joy about doing it. So my sustainability concern is about keeping the whole thing alive, even when I cannot be there the whole time. So basically building a developer experience that we currently don't have, but I think we should have. So this is basically why I started this. So yeah, to describe how we got to this point. Boxes started on 2011 on the early GTK 3, and that's very telling, you know, because it kind of shows that boxes was built how apps at that time were built, and that set the architecture foundation for everything built on top. So we kind of started in a weird path, or a path that made sense at that time, right? I felt that coming from the GTK 2 times to GTK 3, there is still a lot of not well-defined model, template, controller separation in code, and there's not modern concepts that we have consolidated over the years of experiencing and trying things out were just not there, right? It was an open field and people just discovering and learning how to do things. Red Hat was really behind this project. Zishan, Ali, Mark Andre, Alex Larson, and a bunch of other folks for Red Hat were very invested in working on this, and kind of aligned with other Red Hat businesses of the time as well, because Red Hat at the time had like a big virtualization branch and focused on virtualization workloads and remoting. SPICE, which is like a remoting protocol that was sponsored and very well developed by Red Hat, had a whole team around SPICE. And SPICE was allowing you to do remote connections to your display on your local machine, but also remote machines in case of the whole like server virtualization workloads. And SPICE provided the SPICE GTK widget, which is actually using the SPICE protocol to connect to the virtual machine and draw the virtual machine. And that's actually the core of boxes, and actually the hardest part that prevented me from actually porting things in place. Because if I were to port SPICE GTK, then I'm getting to the business of drawing, input, and all the other specifics, like lower level GTK things that I couldn't just take it for granted as an application developer, right? It's not just a widget that can add to my UI, but actually would have to dive into all those fancy input handling and stuff. So, and another thing that happened is that Red Hat kind of moved on, cloud and all the nice things, and virtualization became less relevant, and the SPICE team has been disbanded And Spice kind of became a community project, kind of things slowed down and stalled there. And then GTK4 came, libadweight, flat hub, amazing apps, and I just felt like pretty depressed about how my app looks shitty in comparison. And I felt like really hold back that I had to still support those for our rel use cases, customers that were relying on boxes, and having my hands tied to actually build nice things and having fun doing it, right? Because I was just kind of stuck in this untangled mess and trying to keep it going while like looking at the other side of the fence and everybody having nicer apps. It was kind of a low moment personally, and at the time I also started getting more responsibilities in Red Hat because of internal team rearrangements. So I ended up working in settings. The settings is the graphic interface we manage the system configurations in GNOME. And yeah, that takes a lot of precedence over boxes, especially because it's like very core to the whole RHEL experience. And with the Spice deprecation, Spice was removed from RHEL 9 and 10. So as of now, the only stable supported RHEL is 8, and that's the one we have Spice and boxes. But we don't have boxes in 9 and 10. So very hard to have like a meeting with my manager about quarterly goals and tell them that, oh, I want to work on my hobby project and ignore all these customer issues that I have here, right? So that's how we got where we are. And yeah, I kind of decided to like put the boxes on the back burner for a little while and see how I could go about this and make it fun again. That to me, it became more of a my project type of thing, that I still feel that, of course, it's a GNOME project, it's designed by the GNOME developers and designers, and I've been working closely with Jakub Steiner on this. But I felt that I could be a bit more opinionated or not so much consistent with the core apps, specifically because we're also no longer a core app. Now it's considered more like a developer utility. And so yeah, I end up taking more of a free approach to it rather than just like consistently trying to evolve what we already have. So also the result of me starting in boxes 6 years ago, and starting from the scratch, really like learning virtualization at that point. And I saw at that time as Zishan was leaving the project and they were looking for somebody to replace, and I was kind of like looking for something to do that was relevant. And I was a very heavy user of boxes because of RHEL. I was running a lot of RHEL virtual machines, installing things, testing installation processes and stuff. So to me, it felt like, wow, I actually want to get into this, and I liked it very much. So yeah, so the past 6 years, I like kind of learned a lot about virtualization, and that kind of converged with my experience with GNOME, upstream, front-end stuff. So yeah, that's how I got to decide how I think things should have done instead, right? So it's not like me taking a disrespect of the people who came behind, but more like me taking things from where we are right now, right? So to just kind of put things into place before we get to it, to the new thing. This is how boxes basically is right now. Spice is really core to boxes, right? Spice is the screen, so display when you're seeing your virtual machine drawing there, your keyboard, mouse input, audio, and also that has other channels for file sharing, clipboard, USB redirection. So Spice got pretty fancy at some point. I think it was like trying to be the free software alternative to RDP. Microsoft always was like publishing the RDP protocol specs, but not really like providing libraries for things, and FreeRDP was always like sort of a reverse engineered thing or just based on the specs. But so Spice was really kind of shaped around that idea that you have multiple channels, and these channels can be expandable, so you could always add a channel for sharing another thing, sharing clipboard, sharing USB redirection, so you're just adding up channels. So yeah, basically all the nice front-end features that everybody loves about boxes are actually Spice features, and I've been taking the credit for them. So it was quite an experience of thinking about removing this core part of the app and trying to take it elsewhere with it. The virtual machine lifecycle and creation, destruction, and configuration and stuff is all done with libvirt. We have this saying on the virtualization space that those who don't use libvirt are kind of fated to re-implement it, because you kind of start with the idea that I could just serialize a bunch of QEMU command lines and just get my virtual machine going. And then you start like, okay, but I want this to be customizable. I want this to be variable. I want this to check something in the system and then do something differently based on a configuration file or something. So you kind of end up getting to libvirt, right, which is a library to orchestrate your whole libvirt management application. So boxes use libvirt and QEMU, and oftentimes we discussed, was it for good, was it for bad, it was helping us or actually an obstacle. So there are good points and bad points about using that internally, but that's something I kept. And then GTK, which is like the whole framing around and the widgets that you see. So these are, I would say, the three big things in boxes and where we are. So yeah, the modernization needs the target platform, as I said before. Something that really held me back was the idea that I had to always do these runtime checks, whether the distro had actually created a bridge network. Does the distro actually have support for specific virtual file systems? Or every single feature in boxes had a bunch of checks for runtimes because, yeah, we don't have a target platform. I cannot basically assume that all distros are going to behave the same. Oftentimes, I did even like some sort of analysis, not very scientific or anything, but at some point, like half of the bugs were just basically works for me, doesn't work for you situations, right? It was obscure distributions, packagers. It's just a very complex app, relies on a lot of things, layers on top of layers, and I feel that people who are not really involved on a daily use of the thing are just not really qualified to be distributing it, and I felt that I was just paying that price, and that really was a huge damage to morale, I would say. I feel that myself, Jakob Steiner, we felt very frustrated that things worked for us multiple times, and we had all this negative feedback. I find it very important in software development to do these extra steps of promoting your software, engaging people and things. So I do these Google keywords. I follow everything that is spoken about GNOME, Fedora, boxes on the internet. So whenever some blog posts about something, I get an email about this. So I keep track about whatever is going in obscure Phoronix forums and stuff about our apps, what's being said. I get emails about it. Everything that Google indexes. So it's a lot of negative stuff. So yeah, it's. And as I said before, we also got into this code rot situation where you kind of started on a path of architecturing your software, and then we discover like that this is how modern apps should be built, but we are still kind of stuck on that track. A good example of like this is a procedural generation of widget trees. So you have a machine widget that represents a virtual machine, and it has a memory property. You can change the memory of your virtual machine. So then the machine object in the old boxes implementation would produce a memory configuration widget that would be the returning of a method. And then another widget would just place that in where it belongs in a certain GTK box. So it was really hard to predict how the UI was going to look like in the end. You get an error in there, and suddenly you're missing a row, you're missing an element. And I feel that this is how apps were built in the past, right? Now we are trying to create these pages, this is stateless, and then just trying to bind them to the models. So you kind of have this clear separation about the UI and the logic, and you actually can preview the UI with all the logic actually working. You can stub things up and then get it working, and then just start from there. You can start from the top to the bottom rather than having to meet in between. Error handling was also a consequence of that. There was like extreme use of abstraction. I think like Vala kind of has this Vala Java tendencies, so people kind of have this map from the C# Java world that first thing I do is to inherit some from an existing class and creating layers of abstractions and delegation of who implements what, and you getting deep down into layers. And it felt to me that for like a virtual machine management app, we didn't have to have that much abstraction, that a lot of things were just very generalized for like future use cases, like just in case in the future we start having virtual machines running on your machine, but I'm gonna connect from mine and see your display here. Or in cases where we are going to do that over a secure connection, and just like opening the gates for what might be and not what it really is today. So yeah, that kind of, another thing that kind of was on my way. And the error handling was kind of like, sort of like that, right? We were also having this sort of like maintainer policy of like trying not to expose a lot of the virtualization issues in the, propagate them to the UI, as not to scare the user out and stuff, but at the same time, that created a lot of errors that was just very wide generalizations, like something didn't work. Okay, didn't work. why it didn't work, right? And how do I go about that, right? And I actually kind of correlated to the whole distros are responsible for a lot of the errors, because a lot of the error messages were just basically saying, your boxes was built without the feature that you are looking for. And that was what the error message was supposed to say, but the name of the component that is missing, the name of the packaging, the matching of that, it was just not there, right? So that's something that I also put there. Like, you should look at these points as like a order of priority, right? So those are like the things that I think needs to be done in a priority order. Yeah, so the decoupling about UI and the backend is very critical. I want to be able to engage contributors who are not virtualization nerds and people who are just like, I do live out Wata apps. I want to be able to create a widget that does this, moving this row there, changing labels. And with that procedure generation thing, you're just not doing that. A lot of the widgets were not defined using GTK Builder UIs, and they were composed with other widgets at runtime, and yeah, not something that somebody who was not deep into this process could follow. So it was really an obstacle. And also delegation, right? We ended up implementing a lot of custom widgets because the stack evolved, the design language evolved, and people wanted to see things that were just not there in GTK3, so we ended up using libhandy, implementing a lot of custom widgets, and I spent a lot of time making sure that things were responsive, accessible, and things that the toolkit should be doing. But I was just not able to do because I was not able to use the proper version of the toolkit that actually does it. And another part is in the virtualization side. Virt Manager uses internally this virt install. It's like the module in Virt Manager that does the detection of a virtual machine operating system, and then creating a virtual machine configuration file for libvirt, and then actually calling libvirt to create that thing. And that tool is actually what Red Hat is supporting for the whole cloud workstation. So this is actually pretty developed. Not the UIs, but that tool. So boxes had like fancy code for creating a virtual machine and detecting whether operating system whatever supports virtual device whatever or not. So a lot of matching between what operating system supports and what are the virtual devices that are supposed to be assigned to that virtual machine. Now with virt install, I can do the delegation of basically providing them a file, an operating system, memory, and disk, and that logic is implemented by them. So I also think that they learn a lot from boxes, because I think that the virt install code kind of came from the boxes code, so it kind of went full circle here. I'm now going to depend on them. But it was because in boxes we developed libOS info. It was a Google Summer of Code student my friend Fabiano worked on, and basically a database of describing operating systems, distributions, and what are the virtual devices that they rely on. So boxes kind of end up having a lot of logic about detecting the OS, finding what's the video device for this, what is the audio device, and then creating the virtual machine. Now that's way less code, because now I'm just delegating that to virt install and not really implementing that. So box is really now a shell, and a lot of the virtual machine logic is just reading some specific files and not really like the majority of the code you're going to see. While in the stable implementation, the majority of the code is virtual machine code, is configuring virtual machines, the XML things related to libvirt that we're not implementing, libvirt APIs that we are bypassing, overwriting manually. So pretty glad about not having to implement those things, and whenever I find issues, I can work with the virt install folks, because it's an active developed project, and one of the folks actually sits with me in the office, so we have a very close contact with that. Other workflows as well, also in the last 15 years, a lot changed in the virtual machine space. We were just basically installing distros a lot, getting these ISO files and trying to install operating systems from it. But now with like fast internet and infinite storage, we can just create VM disks and just share those disk images. We can download disk images that have been already pre-installed from things. We don't necessarily need to go through installers all the time to get something going, right? Not all the workloads are starting from the scratch. Sometimes I just want to have a friend of mine installing a virtual machine, configuring something in it, and then sending me that virtual machine over the wire, right? Now I can. It's a 3-4 gigabyte file. In the past, it felt like, wow, who wants to send a 4 or 5 gigabytes file, right? But it can be done now. So I like to support a lot of these workflows of like, I have a virtual machine and I want to share my virtual machine with my friend. I want to make copies of this virtual machine, not really always start from an installation process. So, and the host to guest communication is also something that I want to prioritize. Feels to me that we kind of got in a messy space with trying to do this over the network. We were trying to use the bridge network to do communication, and that relies a lot on the system, on the platform, and platform is not really there. Sometimes you have deployments without network manager, which is just pretty wild for me. And luckily, there is now this thing called systemd SSH generator, or SSH proxy. So it's a very great thing that we get for free from thanks to the systemd folks. But with virtual socks or vSocks, I can SSH into my local virtual machine without having to go through the network stack. So that kind of consistently works for all the guests. Like the guest is the operating system being virtualized. So that consistently works for all the guests that have like a modern systemd. So not for Windows, but I think it's a great improvement. So all in all, this allows for me to do something like SSH and GNOME OS, and that will go on SSH in my virtual machine that has GNOME OS installed. So I can basically SSH in VMs by name. So that's pretty cool, and I end up implementing this on the libvirt side as well. So now libvirt is able to add a vSock alias, so you can actually like create a name for your VM to SSH into. So you can do like a SSH GNOME OS with new modification, and you can create aliases for this, and it's supported by all libvirt now. So it's pretty convenient that all the virtual machines already come with a SOC address, the ones who support it. Right? So yeah, and then attract new contributors. I think that other than code, other than architecture, I want to just basically have good docs. Have a landing page, website, how to get started, support forums and things. I think it's a complex app or like a powerful app in a way, and it kind of requires that, right? I think it's not going to speak for itself just if people are not aware of how to get involved. The new building blocks that I am... to speed up, I think. So yeah, the new building blocks, yeah, Flatpak, right? It's my mini OS distro there that I can just include libvirt, QEMU, and all those things. So now I don't need to rely on the host having anything virtualization related. You can have a very bare bones distro that supports Flatpak, and then suddenly you install boxes, and all your virtualization stack is inside boxes. And that allows me to patch libvirt directly. Allows me to build QEMU with only the architectures that we support. It allows me to build with the build options that distributions are not caring about. Like recently, Fedora decided to build QEMU with a certain flag that was very much beneficial for servers, but just basically kind of made it hard for storage management for like dealing with the disk image for desktops. So I kind of felt like, yeah, kind of powerless regarding this, right? They have a whole business around that, a multi-billion-dollar business, and I just have an app, right? So why are they going to build for me, not for them? So you have my copy of libvirt, my copy of QEMU in your Flatpak bundle. That's great. And then libmks, like a colleague of mine, Christian Haggart, started working on this lib mouse, keyboard, and screen. That's what it stands for. And I think it's focused on this automotive deployments. So basically, you are running a virtual machine inside of a car to do multimedia, like watch a video, and that's virtualized because you don't want that to interfere with the behavior of the car. You don't want your music player to crash and crash the car. So for that, MKS needs to be very well performant because you are virtualizing a video player, so you want to actually have some good refresh rate, and you want things to kind of look nice while being virtualized. So there's a lot of plumbing there to do like direct memory accesses and stuff. So got that for free again. So nice to build things with other people's stuff. And then GK4 and libadwaita, right? Like way less code for composite widgets. A lot of things I get for free as well. So I need to do an analysis on this, but I really think I'm shrinking the code size like in a half. Like it's really perceivable on the new repository how much gets deleted because of all these aspects that the runtime checks, this stuff. Oh, I forgot to mention here the QEMU debuzz display that what libmks uses, right? So Marc André, who was also like an early boxes developer, he's very involved in the whole remoting space. Marc André has created this debuzz display that basically is a debuzz interface that is available for your virtual machine when it's running, and he provides their API for libmks to get like a socket file descriptor for the whole display DMA buffer part. So this basically eliminated the idea that we need to actually connect to the VM. This is actually like how we find the address of the display and how that handshake happens there. So that also was a great improvement. The Kimu debuzz display allows you to query over debuzz APIs the position of the mouse, change that position, allows you to get consoles, allows you to enumerate virtual devices. So basically a debuzz API for the QEMU process. So it's pretty convenient for us to later tap and add like a terminal emulator inside of boxes. So now I actually can have my TTI1, TTI2 of boxes with VTE inside boxes and having that plumbing directly to the VM. So that's pretty neat. So yeah, here's a bit of an overview of the decoupling. The way I went about this was I did a lot of prototyping. I did some conversations with Christian Haggart, and he told me that like he writes a lot of things and then he just throws it away. That he just wants to find how things fits together by experimenting, stubbing and stuff. And I kind of learned a lesson with that, and actually worked pretty well for me. I started creating multiple versions of boxes. One that would be doing things in a certain architecture style, another in another one, and then I end up consolidating in this high-level diagram that I have in here. In Vala, I have this internal project namespaces, so I'm basically separating what is Virt related on the top and what is UI related. So you literally have like a different folder for the Virt files and the UI files. So everything GTK related is going to be found in a specific path. Everything libvirt related, it's separated, and that's very convenient. Yeah, so here I'm getting a little bit more on details on the virtualization ones. So the application class, the top level main application, main class on your application is where things are binded together, the UIs and the backend, the libvirt things. So it provides methods like create, that creates a machine object, open, that starts the machine and then connects to the display of the machine, configure of the machine, and all those like top-level operations that you want to do in your virtual machine. The machine object is more like a data object that is passed along to various things in boxes. So it just holds the data but doesn't operate on that data. And that's really important because this allows me to bind it to widgets. So the machine has a memory property, and then I do a GObject bind the machine memory to the widget that is a spin entry, and then you can just there, like, so you change things and you're already reflecting that on the back end just with the binding, right? I don't need to actually do more complex code for this. The machine also has the debuzz display, so it connects to, it gets the address for that virtual machine that is later passed to the display widget. So the machine kind of does just high-level operations like start and stop the machine and holding that data to be passed along. The libvirt broker is more like the singleton object that connects to libvirt, and that one like basically fetches all the virtual machines that are available on the libvirt installation, opens the connection. So it's more like a high level, manages all my VMs while machine operates in that one VM specifically. The VM creator object is like a GTK, it's something that I'm binding to GTK widgets in the assistant. So when you are creating a VM, you are tweaking the UI, and that's reflecting on this VM creator object. So this VM creator object is something like a builder pattern object. I'm not really familiar in this object-oriented design patterns names nomenclature for this, but I think it's called a builder object when you are basically setting the properties of the object and then making a create call at the end or run call at the end where you take all the data and you do something with it finally. So that's basically the spirit. Has these properties, which are the properties you want to create your virtual machine, and then you can tweak those properties and create. This is very convenient for testing because now I can create a test that just instantiates a VM creator, sets its properties, and then creates a virtual machine for me, and I don't actually need to do through the UI and entry points. VM configurator, very similarly, is the one that operates on the VM that already exists, and that one does a lot of fancier stuff because, as I said, the assistant has like 3 options, which is the memory, the disk size, and the operating system, and everything else is magic. And the preferences dialog, the properties dialog, uses this VM configurator to do the fancy stuff like change the boot order, remove virtual devices. So you want to do a CD-ROM virtual device to be able to boot ISO into your existing VM, or migrating from Spice as well, right? Another thing that I probably should have mentioned in the beginning is that I'm designing this in a way that is going to be a drop-in replacement for the Flatpak. So if you're using the boxes Flatpak, and once this work gets ready, I'm going to be able to swipe the boxes there, and you're going to update into the new one. So it's not going to be a new install. I've been already doing a lot of these experiments with that in various isolated environments to make sure it works. And basically, it's just about going through libvirt and removing all the Spice configurations, adjusting some paths. But it kind of works in most of my tries. Jakob Steiner has been doing this as well. So that's kind of cool. My plan is to basically do this first for the boxes Devel Flatpak, the nightly build. So those using that one might get their VMs migrated to this new display. And the stable one is going to continue side by side, and then suddenly we are going to make the switch. So another great thing about Flatpak that empowering us to do this type of stuff, right? That would be completely unthinkable to do on a packaging, like to replace one app with another like this. Yeah, that being said, there's also the source media class that is also kind of important because it kind of operates on top of the installation source. So you basically select a file in a file chooser, and this is what detects if it's a virtual machine file and what's the operating system inside of that ISO file. So it uses this libOS info to inspect metadata of the ISO and match to the operating system. So it's pretty convenient as well. And here on the UI side, these are the main widgets, and what basically they do is bind to those widgets that I spoke to you before. So the assistant, for instance, has this OS row. You select the operating system, you adjust the memory, and then when you click create on the UI, you actually call in this VM creator create that it's binded to it, so as I said before. The collection is the grid view, and basically the libvirt broker fetches the virtual machines from libvirt, creates that machine object, populates this model, and then I'm just binding to that model. So also pretty small code for implementing a grid, and most of the logic is actually the whole GTK builder widget factory for the collection view and the grid. So much nicer things. And then the custom rows, also nice about the libvirt Weta language that preferences are rows. So I have a bunch of fancy widgets that are just add Weta entry rows or action rows with some fancy suffix or some nice overrides, but still much simpler than what I had before. Oh, actually running bad with time. So yeah, the number of contributors, as I said before, was really low, and I think that people had always historically this scare of treating boxes as complex software. I never saw it that way, but yeah, I can totally see that people can think about virtual machines and operating system into something like, oh, this is kind of simpler, much more complex than, I don't know, image viewer or something, but I don't think that is the case, and I want to convince people that that's not the case. So I am building with Jakob Steiner a website for boxes. I'm using Valadoc, and in this new implementation, I'm documenting very heavily every single method and property that is public. So kind of treating the code docs, the encode docs, sort of as a library, as if I would be documenting a public API, but it's just an app one. But that allows me to use Valadoc to generate this nice website where I can click through the classes and the properties and have nice descriptions, just like you have in valadoc.org, you'd have for boxes widgets. So it's pretty cool. So yeah, top goals here is making it a Flatpak first. I am not really going to be fixing issues with people testing non-Flatpak deployments. I am no longer required to package boxes for Rails, so I am not going to do packages anymore. Don't want to. Testing, as I said, this decoupling allows me to test the virtualization backend. It was just impossible to test before. We were using Dogtail to do before. It was really wild. Click a button, wait 3 seconds, and then click elsewhere, and then your virtual machine didn't appear, so something's wrong. That's the test, right? So now I actually want to do proper unit testing because that's decoupling allows me to do so. And yeah, the issue management discipline, because with all those issues, with fragmentation and stuff, I end up with a pretty full bug tracker. I think I have over 800 issues there, and yeah, a lot of them doesn't work for me, works for you, works on the Flatpak, and it's just wild. So I really want to be able to use this opportunity to start fresh with with doing the right thing right from the beginning to avoid getting into that situation. So most of what I have so far is pushed into this repository. It's in my personal namespace so far because boxes stable is still a thing. But yeah, I plan to actually make this like alpha release or more like a public announcement at GuaDec, so stay tuned for that. I'm also hoping that my talk gets accepted, but my goal at GuaDec is to have something to show that is actually like something you can start using yourselves. Like nowadays, what we have here works. It does most of the boxes features. So like you can create virtual machines, setting memory, operating system. You connect to the display. We can install GNOME OS and all this stuff. We've been testing this with Windows as well. The properties is still kind of short. We still don't support snapshots and other things that we used to support on the other ones, but it's already there in place. So you would be able to use virtual machines for very basic things already with this implementation. So at your own risk, I think you guys should try. But my goal is that at GuaDec, I want to have something at that time, I guess 2 months from now, that that actually can make it to the general audience, and I'm gonna write a nice blog post and everything. So that's basically what I had for today. Here's you can reach out to me. It's my personal GNOME address, and then my Mastodon handler. And yeah, thank you. I think that's all I had to say today. We seem to have 5 minutes for questions, right? Or comments, criticism.
Any questions?
Hi, thanks for the talk. I was wondering if you face it like any challenge migrating from GTK3 to GTK4, anything that comes to mind?
Yeah, I think I was going to face it when I was trying the hard way, which is basically replacing GTK3 with 4 in the same code base, right? Now I kind of started from the scratch, so I kind of decided to build the UIs the GTK4 way and map that to those concepts. So it did not turn out to be really a one-to-one replacement. A lot of things that used to be complex composite widgets are now libadwaita navigation pages or adwaita dialogues. So things that already have a lot of things done for us. So it was not really much of a direct port. That's why I'm kind of calling it a rewrite, not a port. I think it's more accurate because I literally started on a different repo. So.
I tried it last week, and it's great. Thanks for working on this.
Oh, thank you. Thank you very much. Thanks for trying. And please let me know if you have any, if you are trying, please, the issues are there on the repository. So if you have suggestions about how things should be, or if you're a designer and you want to do some mockups, I will be very happy.
Any other questions in the room? I see that in the chats we don't have any questions so far. Okay, we have a question.
Yeah, my second question was about Flatpak and virtualization services on libvirt. I think you said that you packed everything inside Flatpak, so you didn't need any to communicate with the host for anything regarding this?
Just for the KVM device, so there's the Flatpak sandbox hole for accessing the KVM device, audio and networking and stuff, but yeah, everything else is really included in the Flatpak, and it runs this QEMU user mode session, so it's unprivileged. So Boxes has limited amount of features in comparison to the system one, but that basically allows us to bundle in the Flatpak. So yeah, that's why if it works there, because there's never a privilege escalation situation.
How is the communication channel set up? I mean, is it debug service socket, or how does it work?
Communication with the guest operating system?
Yeah.
Yeah, so I actually might have opened here a page about this system, the SSH proxy. So Yeah, I haven't done much with it, but basically systemd has this SSH proxy running on the guest, and on the host there's this SSH generator, I think it's called. And yeah, it seems to set up like this virtual sock, and yeah, I think it kind of handles it all for us. I don't think we do any other fancier things than basically resolving the address. So it kind of handles it that way. Yeah.
Thank you.
Thank you very much, Felipe, for the presentation and everyone for the questions. We don't have any more questions in the room or online, so yeah, I think we are perfect. We have a very short break now, exactly 15 minutes, and we are going to continue with the next two presentations at 11:55 for Europe time, of course. See you later.
Thank you.
you already easily talk with, as you did in that day, and listen, but showing the videos from my lifestyle.
You do.
Hello everyone and welcome back from the short break at day 2 at last. We are going to continue at the second track with the next presentation, an analysis of a changing Linux ecosystem. Alex Paul Gonzalez.
Thank you, Anissa. Okay, so when I decided what I wanted to talk about this LIS, I thought that it was a good opportunity since we have people from all over the spectrum and ecosystem to be having this little bit meta discussion. It's a discussion that we've been having in KDE a lot. I know that also GNOME has had it, and I'm sure that the different other projects have as well. Yes, and Ubuntu. Sure. Or that, no. Whatever. Goodbye. Get the door, please. Yes. Well, first let me introduce myself. My name is Alex. Like Anissa said, I am from Barcelona. I'm living in Berlin. Living in Berlin because I am working these days for Ambition, which is a subsidiary of Mercedes, the Mercedes cars. But that's not what I'm going to be talking about today. Today I will be talking about business that we do in KDE, where I've been developing software for the best part of my professional life, and where I am the KDE president, the KDE being the association around the open source project and community. I'm also part of the Linux App Summit organizing team, and as of recently, I've also been a streamer. So if you want to join us and discuss the topics that we're doing today, you can feel free to join us. We've been doing streams on Sundays afternoon. So obviously, during the last 30 years of Linux that we've had, even a bit more, it has changed quite a bit what Linux means to us. And obviously, as eminently end-user focused communities, we need to have a very clear vision of what that means to us. I'm saying Linux very specifically because I know that there's other parts and implementations of our software that are around and they use our software, but at the moment it's our best bet to reach people, which is in practice what matters, right? For us, it's not important to be releasing a bunch of durables. It's about releasing an experience, something that people can put in their laptops or something that people can buy a laptop and, well, enjoy, right? Like make their life easier, which is in practice what we're about. So when I was preparing this presentation, I decided let's take this step back. Let's see what kind of what has driven us to the state we're today, where basically like we're deciding to do a lot of work that other thankless contributors were doing before, and we're starting to do it increasingly. It started with the applications, and now I see that more and more we are doing operating system-y things, right? So while it's about the kernel, what matters, I guess, to all of us is the user space, and that's what I'm gonna try to look at. First, I'll be looking at how other parts of the ecosystem have done that, like web and embedded, which are actually parts that, while they have different needs, they also have amounts of investments that are vastly superior to the ones we normally get on the desktop, and there's surely good opportunities to learn from because, well, we can see a lot of parallelisms. I'm sure that all of you have done the exercise of seeing like what can we learn from one and another. And I know that like the different approaches are feeding from each other. But yeah, I'm gonna try to just make sure that some things are left said rather than assumed collectively. So for example, on the web, if we think about what was going on in the early 2000s, which is when I started, and I'm sure many of you too, like what was the normal thing was something called LAMP, which was normal web server Linux, Apache, MySQL, and PHP/Perl, depending on who you ask was, right? Which is on systems quite not unlike lots of distros that you can find today, right? Over the years, they started learning about virtualization and containers, which is also, we can see the parallelism with how we've been doing the applications on the last maybe 5 to 10 years on desktops. And right now, what they try to make, for example, when you install a Linux on a server, you're trying to make something that is like a shallow shell, and making sure that like the things that are being run are, again, not unlike application. Not saying that our shells are meaningless. Obviously, like we have lots of more things to do on a system rather than running the apps for the users. Like our shells will be where you configure your Wi-Fi, where you set the size of your fonts or whatever, right? But this is something that the web, they don't need to care about, and then they can focus on having containers. If you were around in the community, like maybe 10 years ago when Docker started being a thing, everybody was saying like, why aren't we using Docker on the desktop? Well, it's not really possible, right? Like the things that it's trying to solve are don't really translate to our users and needs. But we can see that in a way we've evolved in a somewhat parallel way. If we look at this other pillar, the embedded Linux, we can see that they went through a whole similar process. They started with the Linux from scratch and while creating BusyBox, but then they were using lots of the same tooling that we can see still on the traditional distros. And actually the Linux from scratch project in itself is to make it possible to create maybe smaller, more stripped down version of a traditional Linux distro, right? We can see, we know that also they have this problem where like they need to use weird and different architectures. They had, at the very beginning, tons of architectures that most of us haven't never used. But most notably, they have had to worry about ARM, which is the headache of any integrator and distro today. And yeah, if we want to, for example, learn how to do ARM, we will have to be looking at how embedded people are doing it. Something that can be interesting to think about is, for example, how the Alpine story has evolved. We were seeing that, for example, the post-market OS are feeding from that, from Alpine. Alpine, which, as far as I understand, started being a system designed for light systems, but then it was fed into the more web concept that we're describing about, because it allowed them to make smaller images, which, well, it's something that you want both on the desktop, on the web, because what matters to you is your app that you're building on top. And also on embedded, because what you have is like not very powerful hardware. And in practice is what's happening on post-market OS, where like they have, again, not very powerful hardware, and they still want to run all of the features on top of it, and maybe they are compromising on some spaces. I'm sure that they have a good list there, but it's still good for them. But in any case, the big, I guess, evolution has been through how the images are created on those systems. They're not focusing that much, for example, on packages and all of that. Like we would do mostly both on the web and on the traditional desktop, but they're doing what Yocto builds are, which effectively like they try to maybe give you components that are similar to the packages, but the deliverable is like a big fat image that you will flash on your system. And your system, I mentioned here Rauk, but like there's 25 of them because it's a matter of like having this image, making it possible to be put on the disk of that piece of hardware and run it. That's, for example, now something that the Steam Deck is using. Sure that like most of us have hardware at home that is using these systems. We use Yocto at work, for example, as well. Like it's very widespread technologies. Again, I'm saying Yocto. There's 25 other ways of doing it, but point stands. What I'm trying to explain here is that from the desktop and specifically about KDE, which is what I'm familiar with, and I am not trying to speak for anyone else, although I understand that the not saying problems, but like the situation is quite parallel. What we've been distributing traditionally has been tarbles, and it were other people who were putting them together. And for example, I've had the conversation in the past, I remember, like, why do people like produce the images for their smaller devices, but we don't do it in KDE, right? But there's good reasons, there's less good reasons. A good reason, for example, would be that we don't know which hardware we're gonna be run on, right? We can have good ideas, for example, on Intel where things are somewhat abstracted and standardized on ARM is the jungle. And it doesn't seem like anyone wants to fix it, so yeah, we need to learn from the people who have been doing it. In practice, though, here we can, or at least my understanding is that we are squeezed between these two worlds, one about like, that cares about the super detail, and which would be the embedded, and the web, which is like run normally on like much more powerful systems than this laptop, or even the mobile devices, which, by the way, I remember when mobile started, we used to consider it embedded, and we're not really considering it embedded anymore, or at least like from KDE, we're not developing mobile all that different from how we develop the desktop. And in practice, like mobile phones nowadays are quite powerful. You might want to have like certain considerations in terms of battery and things like that, but from an architectural standpoint, you can just go with similar ideas, which is kind of interesting because it allows you to cross-pollinate a lot of the improvements, and like if you need more battery and you make an optimization, then you get it on the desktop and everybody is happier, right? So we are squeezed in this sandwich. And I don't think that we can say, let's fit into either of those because we're clearly a different thing. And we've been doing that through, like, for example, something that has happened as a conclusion of that, probably, is that we might have lost a lot of the user experience because we haven't been owning this part of the story. It has been other organizations, often with bigger resources than the ones from the people actually developing the UX, who have been like putting all of this together, and it has at least created a sui generis kind of community. Like we can see like people joining Linux right now, for example, and saying, how do I start using it? And the answer is super complex, right? Which is like, from a marketing standpoint, like you never want to give a complex answer, you want to give a simple one. And even us here, like we can see that we are not a simple community. In fact, like that's the very reason why we have this conference as well. But on the other hand, it gives us richness and it allows us to work together. So just like I was saying, I want to make sure that things are said, it's not innovation, right? Something that is definitely also specific about desktop, and when I say desktop, like I said, I'm also including mobile. By the way, if somebody is creative enough, come up with a word that is not desktop, that includes the desktop and mobile. Everything is a platform. What isn't a platform, right? Okay, maybe we should have a workshop one of these days, probably with a bit of beer or something like that. What? Raki. Sure. Something that is specific about us is that we have very high bandwidth of communication between the different processes. Like on the web, you will have a massive thing that communicates only with itself. They do a lot of like networking between different processes, but it will even be decentralized that way. Like it doesn't happen within the same within the operating system, which like from architectural design maybe it doesn't make that big of an impact, but from an implementation point of view is definitely relevant. Like we can see like one of the biggest differences between Docker and Flatpak, for example, would be how Docker doesn't really have a lot of mechanisms that we needed to give ourselves to make things simply possible. Right? On the not desktop, but the new words, well, we can see that like the different applications need to be talking to each other, and like you want that your experience is properly integrated that way, right? What we've been talking a lot, and what this conference is about, is the apps. The apps used to be like provided by the operating system, right? Like they used to be a component that was at the same level, both on privileges and at the like. It was even produced by the same people as your shell, right? You could have potentially an application that would destroy your system just like your shell, but since that was your security model, or since that is the security model, that the same people will be knowledgeable enough to like test that these things work, it was fine. And we're moving away from that, so we need to see how that relates. And it brought us to also like this kind of problem, right? Like it's something I had complained a lot about in the past, that like if I had friends using Linux, I couldn't like be developing my application and say, you please try my application, and you would say, no, but I use Fedora and you're using Arch Linux, and like I cannot run a tar file. And then it's like, yeah, you know, whatever. It might be released by your packager one day, right? Which is, again, in the boat we're on and trying to get it addressed. So we've been trying to solve all of these problems. We're trying to make sure that both people can, from the outside, provide their applications, which would be like little tokens of functionality for our people. But we do that both within the security of whatever we've decided. Flatpak has a model, Snap has a model, everybody has, well, AppImage is the wilderness, but like everybody has a concept of what security means, right? And we need to also implement that in a heterogeneous ecosystem, because both like ourselves, we're not always the same, but also like the mindset and the concepts of our app developers will always be different. Like we can even see it on other platforms as well, that people come with their UX, and they like it's not in their in the forefront of their minds to be embedded in the operating system, but have their own look. Like the UX for an application is very much part of their identity. Something that we've always struggled with as a community is that we don't have good ways to sustain people doing things. We try doing that through donations, but donations are only just as good. Addressing that will be very interesting when we get there, but I don't think we are just yet. Also, another problem we have is that ARM sucks. And from an application point of view, it's probably fine, but creating operating systems for ARM at the moment is not something that we're ready, I would say. The only people who have done it successfully, and full respect to them, is Postmarket OS, and we can see how like jungle that is. Like, it is kind of fun looking at their devices page because like you can see, oh, that you can get Linux in there, but like it means that it's only those that are listed and it needs to be a very ad hoc work. Whereas for like x86 devices, you normally would just go ahead and assume that things are working. But in practice, what we're looking into is uniting towards a world where all of these things are possible. Like, it's fun to work on this platform, that it's viable economically, so people can be supported when they work. And yeah, we need to make sure that creator knows how to create the applications for us. This is something that is massively better now than it was before, that people see where to find their information and so on and so forth. If you want to help on all of that, well, make sure to create your apps, and if you have a business mindset, help us figure out how to make money, how to make our people make money. I think that is something very important. Nobody has hit on the nail there. There's been good approaches. Elementary OS people comes to mind, but they also struggled in their own ways there. So, and yeah, talking to people and making sure that things are done is super important. Creating apps, again, is there twice, not by error, but because it's super important to make sure that everything is represented. And before the questions, to give you a mindset, like, we got to this, to having this conversation because we understand that for us, for us being KDE, delivering a user experience to the users is super important, and that goes down to providing themselves not only like maybe the operating system, but also the devices. Like, for example, this one device is a hardware collaboration with it, and it's always a matter of making sure that our users are getting what we offer. And when we cannot make sure that this is happening, things start to get lost. We can like hide behind our hands and make it as if it wasn't a problem. We've all done that. I've done that. All of you have done that. But I think that knowing that these problems are a thing and seeing to address them is very important. So yeah, that's what I wanted to talk about. If somebody has a question, I think we have a couple of minutes, and if not, I'll be around for the rest of the conference.
Thank you very much, Ale. We really have just 2 minutes because then Alesh has to be in the next track because we start a panel. So yeah, any questions? We have people from the audience running because they just remembered they have a panel they have to be in.
All right, then the questions can go in the panel.
If people online have questions, so far I don't see anything in the chats. If something comes up, we'll ask Alesh to just take a look and respond there.
Yeah, thank you.
Thank you, everyone. See you in track 1. Track 2 is going to be like shut down for now. Oh, I see, sorry, if there are people still online, I see we have a question just arrived. So, question for Alesh, is there any place to see draft code previous streams?
If they're not on Twitch, they're not available. I know that Twitch does store some, but not all of them. So check it if it's there. If it's not, well, I don't know, be louder. You can also donate. If we have donations, we will have more incentive to have this stored.
Thank you very much for the question. Thank you, Alesh. See you at track 1, at the panel. Thank you, everyone. See you later.